Okay, and now it gets even cooler. Okay, so do it again, step by step. The first two equations here are the starting point. These are your momentum equations. If you want to predict the u and the w for the next time level, n+1, you have the first guess velocities, which are these ones here. You can calculate them, but you essentially don't know these terms here on the right-hand side because there's an n+1. n+1 for the next time level. And you can see that there includes the index k and the k+1, and also the index I-1, and it's actually above, and the current index within your grid, k+1 is to the right, k is the element. So now you insert these equations into the continuity equations. Okay, this is also you formulate that in the finite difference forms. And if you get confused now, you look at your poster. You know, I told you print out the Arakawa C grid, and that tells you exactly what you have to use, whether you have to use k-1 or k+1. So you have to look at it. You are in a certain grid cell, and now you can work out how you calculate it. And if you do that, you get the equation that you need to solve is this one here. It's one equation and all the unknown on the left-hand side of the equation, and everything you know is on the right-hand side. There's a star, and it all includes here is this one is what the Q star is. All knowns. Okay, it has the first guess velocity. Okay, have vertical components, everything in there on the right hand side. But how do you solve one equation which has 5 unknowns? Have a look at the structure of how it looks like. Okay, you have some coefficients. These are these A, E. By the way, E means east, W means west, E means top, B means bottom. Okay, so you have them, and essentially what determines these coefficients is the ratio of grid spacings, delta x divided by delta z, or delta z divided by delta x. And this A0 is actually the sum of all. Anyway, so you need to solve one equation with 5 unknowns. And once you have found this solution, you can do the prediction for the next time step. This is the challenge. And again, if you look at the index, you actually have to find the solutions for 5 adjacent values of Q. The central value, the one above it, the one below it, the one to the east, and the one to like a star. You need to, or a cross, and you need to solve all of these. Again, but there's a way to do that, and you can do that with another iteration. So this equation can be solved with an iteration that goes and goes and goes and repeats and repeats and repeats until you meet a certain conditions, until the errors actually turns. And we come to that on the next slide.